All right, hello everyone and welcome. I hope you all had a great weekend. I think we all know what the big thing on today's agenda is. My goal today is to get you as prepared for the exam as possible. So I'm going to start by discussing the logistics a bit. That'll probably take 5 or 10 minutes, and then we'll spend the rest of the time hopefully just going through problems and writing code and talking about code and all that fun stuff. So let's talk logistics. I know this is the first computer science exam for many of you, and it is also an evening exam, so the exam is going to be taking place this Thursday from 6:30 to 8:30 p.m. So it is an evening exam. It's taking place this Thursday evening. I just got the room assignments from the exam today from the university, so I have not had a chance to post the room assignments yet. However, it's based on your ID number, so it's based on the last 3 digits of your ID number specifically. I'm gonna go home later on this evening and figure out, who needs to go to what room and update this page. I'll also post an announcement on Piazza once I've gotten that finished. So please keep an eye out for that information. It will not be in this room. I don't think this room is even on the list of rooms that we have. So please, 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 sometime between now and Thursday, hopefully you get that announcement from me, but even if you don't, remember to check where you're supposed to go. We will not be here. So please check where you're supposed to go. If you haven't been to that room before, it might be a good idea to go there and make sure you know where it is, because we are going to get started at 6:30 on the dot, and the exam will end exactly at 8:30. So you have 2 hours to complete it, which should be plenty of time. If you have accommodations, especially extended time accommodations, we will not be able to give you those accommodations in our exam rooms. You hopefully have already contacted DR to set up a time to take the exam if that applies to you. You can come take the exam with in one of the exam rooms if you would like to, but we will not be able to give you extended time. You'll have to finish at the same time as everybody else. So if that applies to you, please, please, please make sure you talk to DR and get things set up to take it through them. Otherwise, the other things you should be aware of are what you should bring. So no electronics of any kind are allowed on the exam. No computers. Actually, what I get asked most often is about calculators. While it is true that there might be some simple arithmetic on the exam, there's not going to be any math on the exam. I mean, honestly, I expect it to be done easy enough to be done in your head, but maybe on the margins, if you have to do a little bit of arithmetic, it should not be any more complicated than that. You should not need a calculator. Should not be necessary. Any math that you're asked to do will be very simple, very straightforward. It's not a math exam. It's a computer science exam, so I'm not interested in how well you do multiplication and division. I trust that you can do that stuff just fine. So what you can bring is a sheet of paper with notes on it. So just a regular size sheet of paper. Notebook paper is fine. Printer paper is fine. I'm not going to walk around with a ruler, right, and measure your sheet of paper to see if it fits a certain standard. It's just a regular sheet of paper. If you walk in and you've got a big old piece of poster board as big as this desk, I'm gonna, have a conversation with you about that. That's not really what I'm looking for. Just a regular size sheet of paper. You put whatever you want on it. There's absolutely no restrictions on what you put on that sheet of paper. You can use both sides, front and back. You can type it. You can write it out by hand, right? Whatever you want to do. You just got one sheet of paper, front and back. The only other request that I make is that if I'm walking through one of the exam rooms, and I may actually do this, and I say, hey, can I see your cheat sheet? I should be able to read what's on your cheat sheet without any additional devices or things like that. If I have to put 3D glasses on, right, to read your cheat sheet, we're going to have a conversation about that, right? That's the point I'm trying to make. If I have to put on one of those new Apple VR things to read your cheat sheet, well, no electronic devices anyway, but we would have to have a conversation about that, right? So don't try any funny business is the basic moral of the story. Just keep it simple, straightforward. If you want to write really tiny, okay, right, as long as I can see it, that's fine. And then the other thing that I like to talk about is what to expect on this exam. Hopefully you've already seen, but if you haven't already seen, I definitely want to bring to your attention the fact that I have posted some materials that you are are specifically for prepping for the exam. This is a quiz. This is a practice quiz. It does not count for credit, but this is a practice quiz. This contains questions from past exams. These are quite literally questions that have been ripped from past exams. Every semester I go and I add the previous semester's questions to it. So this is just a running list of multiple choice, true, false, fill in the blank style questions that have been on past exams. This second one here, this is a coding repository. So much like how you make a new repository in Eclipse for every assignment, this is one that's specifically focused on exam prep materials. And so if you take a look at that repository, it's broken into two categories. These are non-exam problems. These are just extra practice. So these have not been on past exams, but are considered good coding problems for extra practice. Everything that you see in this folder called past exam, these are, again, questions that have been on past exams. I ripped them directly from past semester's exams. I do have to make a little bit of tweaks sometimes, but for the most part I try and stay true. And they come in two flavors, code reading and code writing. So these ones you have to read the code and tell me what it's going to say, and these ones you actually have to write Java code to solve a problem. So in terms of what to expect on the exam coming up on Thursday, I understand that there can be some anxiety about these things. There's a lot of unknowns about the exam that's coming up, but I want you to remember the purpose of the exam is for you to show me your knowledge of computer science. So one of the questions that I get asked frequently is something like, how many multiple choice questions are going to be on this thing? I got to be honest with you, I don't even know. I haven't written it yet, so I could not tell you even if I wanted to. But I don't want to, because I also think that me telling you, if I told you right now that there are 12 multiple questions on the exam, would that change how you study? I don't think that it would. What kinds of questions are going to be on the exam? I just showed you. Multiple choice, true, false, fill in the blank, code reading, code writing. That's all going to be on there. All of them. How many? I honestly don't know. I'm not testing you on the format of the exam. I'm testing you on your knowledge of computer science. So probably the question I get asked most often, how do I study for this thing? How do I study for this exam? What's the best way to study for this exam? Well, that is a largely personal question. I hope that you have done some work internally on yourself to figure out what studying methods work best for you and which ones don't. But as some general suggestions, make that sheet. That is actually part of the studying process. When you're making that sheet of paper, you're identifying which areas of knowledge you feel confident in versus which areas of knowledge you maybe don't feel so confident in and maybe need a little extra help with. That's good to know, right? That's good self-awareness because obviously if you understand for loops really well, I'm probably not going to put a lot of for loop stuff on the sheet. But if you are struggling with arrays, then I'm probably going to dedicate a large chunk of that sheet to arrays. That's good. That's good to know going into the exam. Focus on the areas that you know you need to focus on. The other suggestion that I have when people ask me, how do I study for this exam? Coding is a skill. And like any skill in life, you get better at it with practice. So listening to me talk about code, while valuable, is not nearly as valuable as you writing code yourself. Get your hands on that keyboard, write as much code as you possibly can. I have given you so many problems, so many problems on which to practice. If you complete them all, then Java is the most popular programming language in the world. There's absolutely no shortage of practice problems available on arrays if that's what you need practice on. So please write as much code as you possibly can. That is the best way to get better at writing code, is to write code. And if you get stuck, that's what we're here for. Be happy to help you either on Piazza or the other thing that I wanted to bring your attention that is kind of exam related. Because of the exam this Thursday, There's no new topic this week, right? So there's no studio this week. So what does that mean for Wednesday/Thursday? We will still be there. I'll be around, although I'll also probably be in the copy machine making a bajillion copies of the exam, but I'll be around. The TAs will be there, right? The TAs will be in class. Do you have to be there? There's no studio, so we're not going to go around and take attendance and see if everybody's there or not, right? If you want to come in to turn in a homework assignment, we'll be there. You can do that. If you want to come in and ask questions about the upcoming exam, maybe there's a problem that you want a TA to go through with you, we'll be there. You can do that. In fact, that's a great way to get some one-on-one attention from an instructor or a TA is to come into class on Wednesday or Thursday. But as I mentioned, there is no studio. We're not going to be taking attendance or anything like that. It's up to you to decide the best use of that time. So please come in if you need to submit an assignment, ask questions about the homework. Otherwise, it's up to you how you wish to use that time. I think that's the end of my rant. Does anybody have any questions about logistics, what to expect, anything like that before we hop in and talk about some actual coding stuff? Any questions? Yeah?
Should we plan on demoing our assignment 2 next week then?
So assignment 3 is still due this week, and that's, I mean, that content is on the exam. So I want you to do that assignment and get it done.
Are we going to demo it next week though?
You can, but it is due at the same time. It is due this week. So if you demo it next week, it will use late coupons. You can always submit it early if you don't want to come to class on Wednesday. If you have your assignment submitted via office hours tonight and you don't have any questions about the exam, then you're an adult. You can choose how to use your time the way you want to, right? But assignment 3 is due this week, and it will be on the exam. So do with that information what you will. Any other questions I can answer about logistics before we do some coding? Look at some code, write some code, hopefully. Okay, great. So we've got about an hour, a little more than an hour. I would love to go through as many problems as possible. Often I do understand that students are focused on the exam and they want to ask, maybe to go through some of these code writing questions that have been on past exams or code reading questions that have been on past exams. But you're welcome to ask about anything. If you want to ask just about a topic in general, be happy to talk about that. If you want to ask about anything from past studios or I guess I won't answer stuff about like assignment 3 because that's not due yet. But generally, I'd be happy to talk about arrays. But yeah, I'm hoping that somebody will have some questions for me or point me in a direction. Otherwise, I'll probably just start picking problems at random to go over. So does anybody have a topic, a practice problem? Does anybody want to steer the conversation towards something in particular? Anybody have any suggestions for me? No? Yes? Arrays. I kind of expected that to happen. All right, let's talk about arrays. I think, I'll probably do at least a couple problems with arrays today. I imagine it's a very common topic. Maybe let's start with one that's a bit more on the one-dimensional side, perhaps, and then we can also look at a two-dimensional example as well. Do I even have one that's just one-dimensional, or are all of these two-dimensional? That one doesn't even have arrays. All right. I like this problem. It actually does use a two-dimensional array and a one-dimensional array. So let's just dive right in. We'll talk about both. That's okay. It's a good problem. I like this problem. All right. You're given a two-dimensional array of integers called data. Here it is right here. Remember that, what's the position of this one? How would I get this value back out? What's that position? 0, 0. We start from 0. So arrays start from row 0 and column 0. Always start from position 0. It's not row 1, column 1. It's row 0, position 0, column 0. Okay, so we're given this two-dimensional array of data, and we wish to do what's called sampling. We're actually making a random sample from this two-dimensional array. So I wish to randomly pull n values from this array and then create well, actually, it's already been created for us. This one-dimensional array is where I wish for those values to go. So if I say, it asks the question, how many random points would you like? And I say 3. I want 3 random points. Then, maybe I'll pick the 4 and put that one in here. And then maybe I'll pick this 2 and then put that one in here. And then actually, maybe I'll pick the 4 again. There's actually nothing to stop me from randomly picking the same value twice, right? It just said pick 3 random values, 3 values at random. Okay? Possible to pick the same one twice. That's totally okay. Not a problem for us. Before I start writing code, just maybe a few more logistical things to think about on the exam, things to be aware of. If you need the scanner, notice that I provided some code here for you to start with that includes the scanner. So if I'm asking you to, ask the user for input, I will give you the scanner code. I will give you the code that you need to set up the scanner on the exam. I think it's reasonable for me to ask you a line that looks like this. I may not always give you this line of code. You've written lines of code that look like that. So I think that's a reasonable thing to ask you. But stuff like this, I will give to you, right? I will give that code to you. You don't have to memorize that. You don't have to waste your sheet of paper on that, right? A lot of times I'll give you the scanner code. And actually, I'd also like to state that in the reverse, because this is another common thing that I see on these exams. If I do not give you the scanner code on a particular problem, don't put it in. Please, please do not put it in there, right? A lot of times students will get maybe a little bit carried away and try to use the scanner to ask the user to type in information when I didn't actually ask for that, right? That's not going to be on every problem. We only use the scanner when we want to, right? So don't force it. If the scanner code is not given to you, you should not add it in. You should not put it in. That probably means I don't want you to use scanner on that problem. If I do want you to use scanner on that problem, I'm going to give you at least this, and oftentimes a lot more, to give you a push in the right direction. So just want to make that clear. All right. We now wish to solve this problem, and one very, very common thing that we talked about when dealing with two-dimensional arrays is this nested for loop structure, right? So we have this nested for loop structure, and we went so far as to say that, I usually use the first loop for the rows and the first loop for the columns, right? I'm actually going to make the claim right now that we don't want to do this on this problem. So be careful. Is it true that nested for loops and two-dimensional arrays go well together? Yes, absolutely. That does not mean that I'm always going to use these nested for loops every single time I have a two-dimensional array. Think carefully about what it actually is that you're being asked to do here. This structure, this nested for loop structure, is very useful because it allows us to visit all of the rows and all of the columns, right? So if I need to visit each and every value in this two-dimensional array, then this is great. Is that what I need to do here? It is not. I need to pick values at random. It is entirely possible that some of these values will not get picked at all, right? That is a possibility. I do not need to visit each one of these numbers. That is not a necessary part of this problem. I am being asked to randomly pick these values. So maybe I'll use them all, maybe I'll only use part of them, right? It's random. It's random. So nested for loop actually not what we need here. We use loops for repetition. So the repetition that I need to do here is based on what? What's the repetition based on? Not the number of rows and columns, but what am I doing multiple times as part of this problem? Getting random numbers. Yeah, getting random numbers. I need to generate random values specifically. So it says, how many random points would you like? N random points. So I need one for loop that is going to run n times. I need one for loop that is going to run n times. Not a nested for loop. Not for this problem. It's not necessary. Does everybody understand that, I hope? Okay. Now let's talk about how to generate random numbers, because this is actually a concept we've talked about many times. What random numbers do I need to generate? Well, if I want to pick this value out, I actually need two numbers. I need a row and I need a column. So I need a way to generate random rows and I need a way to generate random columns. So I would argue that every time through this loop, I actually need to generate two random values. One for the row and one for the columns. Even more importantly than that, perhaps, is the idea that if I generate a random row, it has to be valid, right? So I have two rows here, rather. I have two rows here. If I generate, a 5 as my random value for a row, that's not going to work. There aren't that many rows. So I want to make sure that the random row that I'm telling you to look at actually exists. I want to make sure that actually exists. So there's a way to generate values in any range, in any given range. We've talked about this before in class. And I'd like to go through it with you again now because I think it's important. I'm going to write it out kind of as a formula. So I'll show it to you in kind of a general form as a formula first. But then we can also maybe talk about how we could apply it to this specific situation as well. The formula, so the number of, if we think about it, the valid numbers for rows would be either 0 or 1, right? But if I had another row out here, then the valid numbers would be either 0, 1, or 2, correct? So the first thing I think that's important to do is to compute the range. What are the random numbers that I wish to generate? Between what and what? What's the lowest value that I want to generate? What's the highest value I want to generate? So the range in this particular case is based on the number of rows or the number of columns, depending on which random value I'm talking about. How do I get the number of columns out of this array? Or I'm sorry, number of rows out of this array? We'll talk about both, but let's start with the rows. How do I get the number of rows out of here? How do I ask this array how many rows it has? Anybody remember? Dot length. Data dot length tells me the number of rows. If this was a one-dimensional array, it's not the number of rows, but just the number of things in the vector, in the one-dimensional array. But we're talking about a two-dimensional array, so this is the number of rows. So think about what this means. This means that, if there are 3 rows, the range of values that I can produce is actually 3, 0, 1, and 2. Right? 0, 1, and 2. So the first thing to do is figure out what your range is. My lower bound, or another way to do it is to, compute that based on your lower and upper bound, which, lowest possible random value, right? Okay, now let's talk about generating the random values. We use math.random for generating random values in this class. What does math.random give back to me? I say math.random and it says, anybody remember? 0 to 1. Yeah, some value between 0 and 1. However, remember, it does not include 1. So 1 is not part of that process. Okay, so that's not what I want. I don't want a value between 0 and 1. I want an integer value that is, either 0, 1, or 2. Or it's based on the number of rows, right? So in order to do that, I'll multiply by the range. I'll multiply by the range. I think it can be helpful to work through, well, let me finish the formula first. And then I'm going to add the lower bound. I'm going to add the lower bound. I think it can help to work through what would happen if math.random gives you the smallest value it can, and then if math.random gives you the largest value that it can, and kind of think about what values you would get back. So if this gives me 0, 0 multiplied by whatever the range is still going to be 0. That's easy. And then I add on the lower bound. So that's actually also still 0 in this case. But remember, we're trying to do this in a general way. So if the values that I wish to generate were between -10 and +10, right? So this would be -10. My range would be something different. It would actually be 21 in that case. From -10 to +10, that's 21 different values. Don't forget 0. Don't forget 0. So that's 21 different values. So let's think about what that would be in this case. If this gives me 0, still doesn't matter what the range is, that's 0. But here I'm generating values from -10 to +10, so my lower bound is -10, right? If math.random gives me 0, that should give me the lowest possible random value that I want, which is -10 in this case. Or, if we're talking about the exam problem, it would be 0. All right, if math.random gives me the largest possible value that it can, that's going to be 0.9999999 repeating, multiplied by the range. So if we're talking about the range from -10 to +10, the range would be 21, meaning that I would get a value of 20 point something, right? 20 point something. I'm adding on the lower bound, which would be -10. That's going to get me a value of 10 point something. But I don't care about the point something, so I'm going to cast it to an integer. And when I cast to an integer, that has the effect of truncating the decimal, just chopping it off. It does not round. It chops the decimal off and throws it away. So if we think about this formula, I'm making the claim that this right here, right, will generate random integers in the proper range as long as I'm computing the range and the lower bound properly, right? Substitute those out for any range you can possibly conceive of. And this statement will work in the general case. This statement will work in the general case. Are there any questions about that? I know I'm talking to you about this in the general case. We can actually make some simplifications on this particular problem, but it is entirely possible that I give you a problem that says generate random numbers between -50 and +50 on the exam. And so you would need this, right? You would need this. The range between -50 and +50 is actually not 100, but 101. It's 101. And if you plug in the values here, you'll see that if I use 101 and -50 as those two values, that this will give me values in the range of -50 to +50. You can even run the code yourself a few times and verify if that's the case. For the purposes of this problem, since the lower bound is 0, right, this is actually extra. And so a lot of times we can actually see people simplify this problem like so. I'm making the claim that this statement will always give me a valid random row number. So if my array has 5 rows in it, I'm making the claim that this statement will always give me 0, 1, 2, 3, or 4. If my array has 3 rows in it, I'm making the claim that this statement will always give me either 0, 1, or 2. If you don't believe me, then do what I just did. Think about the case where math.random gives me the smallest thing that it can. Do the math. Think about the case where math.random is going to give me the largest thing that it can. Do the math. you'll see that 0 is the smallest thing that I can get back out, and 2 is the biggest thing that I can possibly get back out. Again, if you don't believe me, you can run the code and try it out. There is a very similar statement then for generating a random column. I just need to swap this out with the statement that we use to ask for the number of columns, and I actually sort of spoiled it a little bit there. I was going to ask you how I do that, but I kind of spoiled it. This is how we request the number of columns from an array. The way to think about this statement is go to my two-dimensional array, fetch row number 0, and tell me how long that row is. The length of a row is equal to the number of columns, right? If a row has 5 things in it, that means there's 5 columns. So I am now making the claim that similar to this line will always give me a valid column number. If I have 5 columns, then this line will only give me 0, 1, 2, 3, or 4. That's it. If I have 10 columns, then it could give me values from 0 through 9. And again, if you don't believe me, work through it. Do the math. If we accept that those are okay, we're actually almost done with this problem, believe it or not. We simply have to extract that value from the array. So our two-dimensional array is called data. Because it's two-dimensional, I need two numbers to access it. What's it called when I plug a value into an array? The bucket number. What's that? What's the word for that? The official computer sciencey word? Index. Yeah, I need 2 indices. So row, column. That will extract that from my two-dimensional array. I need to take that value and put it in my one-dimensional array. So I'll put my one-dimensional array over here on the left-hand side. This isn't quite done because I have to say where I want to put it in this one-dimensional array. Well, pay attention. I mean, this runs n times. My array is also of size n. That's not a coincidence, right? So I think we could use our loop variable here, I. This is the solution to the problem. This problem is done. This problem is finished. A lot of people are kind of surprised when I say that because look how short it is. It's like 4 lines, 5 lines of code, right? You could have used more. Sometimes people want to make extra variables for things, and that's fine. I don't have a problem with that. But really, I mean, notice that the solution is not very long, and I think that's a good test-taking tip for you as well. If you find yourself writing a solution that is 30 lines long, 40 lines long on the exam, will it work? Maybe. I mean, we'll still grade it, yes. But that's definitely a flag that you are taking a more complicated path to the solution than what was expected. Again, not necessarily an indication that you're wrong. It could still work. I've definitely gotten solutions that fill up, the entire page that still get the job done, and you will get full credit. You're not being graded on how short your answer is. You're being graded on whether it works. But I am not going to intentionally ask you a question that requires you to write 100 lines of code. That is not a thing I'm going to do. All of these questions can be answered in a handful of lines. So keep that in mind. The other thing that I want you to keep in mind on problems like this is this right here. I think this is important to take notice of. I gave you some actual numbers here so that you could actually run this code and try it out. In fact, I think that's important to do. We'll come back and try that in a second. But I also think it's important to note that if you see a problem like this on the exam, you're likely to see not actual numbers there, but something like this. I'm not going to give you actual numbers. I don't actually care about the numbers. I don't care about the numbers. I care about, can you write the code to solve the problem? Or another way of thinking about it is, I want this code to work regardless of how many rows and columns the array has. So I definitely don't want you to look at an array. Whoops, didn't mean to do that. I definitely don't want you to look at, you know, an array like this and think, okay, I can just write 2 here and 3 here for the number of columns. Will that work for this array? I mean, yeah, it will. But if you're practicing this on your own, if you're studying this on your own, I would encourage you to add another row and test your code. Does it still work? Add another column. Test your code. Does it still work? Take a row away. Oh, that's actually, I think, a big problem. Well, maybe it'd be easier to take a column away. But yeah, take a row away or take a column away. I think that's actually a big problem, right? Because this still says I have 2 rows and 3 columns. This could generate a value of 2 for the columns, but I no longer have column 2, right? Column 2 no longer exists. I took it out. This would cause an error. Oops. Oh yeah. There it is. Boom. This will cause an error. Index 2 out of bounds for length 2. Column 2 doesn't exist anymore. So the proper way to do this is to make sure that you're asking the array how big it is. I'm making the claim that by doing it this way, if I add a row to this, if I take a row away, the code still works. If I add a column, I take a column away, the code still works. This is the proper way to do it. So if I run this now, you'll see that I don't even have any errors, right? I don't see any output either, though. We actually can't, I mean, the question didn't ask us to print anything. There's nothing that says it needs to print anything. But let's say we wanted to. Let's say we wanted to see the actual values that got picked. I would like to do that, and in order to do that, we need another loop. But I'm going to take a second to discuss a different style of loop with you. How about a for each loop? We did talk about this. I'm going to use a for each loop to print out the contents of this array. The big difference between this style of for loop and the other style of for loop, the for each loop, is that I'm not going to see any semicolons. I'm going to see a colon in there. So that's a good thing to keep an eye out for. If you see a colon inside the parentheses, that is a for each loop. If you see semicolons, that's a regular old for loop. The other thing to keep in mind is this loop has 3 pieces. 3 pieces. Initialization, condition, update. For each loops only have 2 parts. The first part is to declare your loop variable, yes. So type, this is a name where I get to pick the name, right? I called it value, but I could have called it anything. I could call it v, I could call it after this is a terrible variable name, right? A terrible variable name. Please make it more descriptive than that. But yeah, I get to pick the name. And then what comes after the colon, that is the array. That is the array. The way that I would read this in English, if I came across this, I would say for each. The colon tells me that it's a for each loop and not just a regular for loop. So for each integer value in the points array. That's how I would say that in English. For each integer value in the points array. The way that a for each loop works, the first time I go through the loop, value is going to have whatever the first number of the array is. The second time through the loop, value will have whatever the second number of the array is. Let's actually try this out. I'm going to show this to you in a couple of different ways. All right, I'm just going to do 10 random values this time. And here are the random values that have been selected. 5, 5, 4, 2, 2, 5. You can see that it does allow for repeats, and that's fine. That was part of the problem. But actually, I want to take a second and walk through the debugger. I love walking through problems in the debugger. if you get stuck on a code writing problem, if you get stuck on a code reading problem, maybe we'll do some of those a little bit later. Using the debugger is a great way to try and figure out where things are going wrong, or understand the part of code that's got you stuck. So I set a breakpoint on the exciting part, line 33, and I'll go ahead and tell it I want 10 random points, and then let's see how it actually does this. Here I am in the loop. First thing I'm going to hopefully do is generate a random row and column. So it's telling me that I'm going to start with row 0 and column 0. Okay, happen to pick the top left corner, and I know that should be the value of 1. So I expect the value of 1 to be taken out of the 2-dimensional array and put into the 1-dimensional array. Here's my 1-dimensional array over here. You can see right now it's filled with 10 zeros. It's empty. But once I run that line, there's the 1 that I randomly selected. All right? And then we go through again. This time I'll select row 0. Oh, wow, I got the same. Okay, well, that happens, right? Sometimes I'm going to pick the same value. So I got row 0, column 0 again. There's a 1 in the second slot. All right, let's see if we can get a different one. Row 0. Come on now. Now I'm wondering if I'm doing something wrong or if I'm just getting, like, really lucky. Row 0. Hey, now. What? This is... All right, now I'm worried I did something wrong. What did I do wrong? Or is it really just picking the same values every time? I mean, it's possible. Should I go buy a lottery ticket after class? Oh my gosh. I should. It just picked 0, 0, 1, 2, 3, 4, 5, 6, 7 times in a row before giving me a different row column pair. That's pretty amazing in my opinion. I'm going to go play the Powerball after work today. Yeah, no, it's definitely choosing random values. I just got, like, incredibly lucky. Wow. Okay. Yep. So picks the random value in row 1, 0. That's going to be this 4, right? So I expect the value of 4 to pop up. There it is. And then I've got one more random value to select, row 1, column 1. So that's going to be the 5, right? Fill that in. So I've got my random array of points that I have filled. This loop is finished. It's done its job. And now we're down to this for each loop. So if I step through this for each loop, notice that the first time through the loop, value has a value of 1. That is the first value from the array. It does start at the beginning and work its way down in order. So that means that we're going to see, 1 pop up 1, 2, 3, 4, 5, 6, 7 times in a row before we see something else. So here we go the first time. We'll see them show up down here at the bottom. Here comes the second time. Third one. Oh no, I hit the wrong button. Sorry about that. Third one, fourth one, fifth one, sixth one, seventh one, and now finally at the 8th position we see the 2, the 4, and the 5. And we're done. Once we've finished going through all of the values from the collection, the for each loop ends. This was not part of what was requested on this problem. I just thought it was a good chance to talk about for each loops and print out the array, so that's why I included it here. Again, just as a refresher, the code I have highlighted right now is what I would consider to be the official quote-unquote solution to this problem. Although there are many different ways you could have solved it. Does anybody have any questions? This was a tricky one. I started us off with one of the more tricky code writing problems in my opinion. But does anybody have any questions? Would anybody like me to go back and explain any parts of it over again? Be happy to do that. Does anybody have any suggestions about... Oh yeah, question, sorry.
I think before you had said to add 1 to the range because of truncation. I just wanted to clear that.
Yeah, let's talk about that. So that was the question was about computing the range for random values. So if we're thinking about computing the range, like I use an example of -10 to +10, right? The claim is that there's actually 21 possible values there because 0 is a possible value that is in that range. So when computing the range, if my range is from -10 to positive, let's say int int high is 10. Oops, forgot the semicolon. Ah, that's still not a semicolon. All right. And int low is negative 10. That time I forgot an equal sign. Okay. The range is going to be high minus low, but that actually would get me 20. So I need to add 1 to the range to account for the fact that 0 is included in there. Although even if my range is all positive, let's say my range is from 50 to 100, I would argue that this is still in fact the case. There are 51 possible values that could be generated here, 50 through 99, and then including 100. So I need an insert here as well. Yeah. So there is that additional factor of 1 with the range to be careful about. That is a common problem too, by the way. Actually, if you were here in the last session, I don't know if any of you did, I think I actually made a mistake with this 1. It's such a common problem. Off by 1 error is what it's called. It happens all the time. I make this mistake all the time. So it's an easy thing to miss. I'm glad you asked about it. Yeah, and so then, you know, just to kind of finish the right? This is maybe a better way of thinking about generating random values in the range, right? Swap these high and low values out for whatever numbers you want. For whatever range you want, I'm making the claim that this code will work. You give me, I want random values from negative 10 to positive 10. This code will work. I want negative values from, you know, negative 5, negative 15 to positive 100. This code will work. Right? That's the claim that I'm making. But don't just take my word for it. Work through the math, try it out yourself. Have the computer generate 1,000 values. Make sure none of them go above 100 and below negative 15, right? Try it out. That is a thing you can do. Great question. Any other questions on this one before we switch to something else? Yeah, what's up? How do you actually use the debugger? So step 1, set a breakpoint. I usually set the breakpoint on what I call the exciting part. So declaring variables, I don't consider that very exciting. Loops are usually where the complicated stuff starts happening, so that's a common target. But it doesn't have to be a loop. You can set a breakpoint wherever you want, but I typically look for where the action starts, and you just double-click the line. And then instead of starting with the green circle, you'll start it with the little debug instead. That has the effect of pausing the code once it reaches the breakpoint. So I do have to still type this in. And then it's going to actually pause and let me examine the values once I hit that breakpoint. And then in order to step through the code, that's what these yellow arrows are for. We've so far just been using this yellow arrow called step over. I will eventually show you what this one means, but we haven't had a need to use it yet. So this is the one that I use. I would also like to, since we're on the topic, you have this in writing. We ask you to do this as part of Studio Zero. So if you need to go back and read those instructions, it's all there on Studio Zero as well. Any other questions on this one before I do something else? Go in a different direction, perhaps? Does anybody have a problem they want to see me do, or a topic? Yeah.
Can you talk about, let's say you have an expression with different data types in it.
Okay.
How it resolves to
Okay, yeah, let's talk about data types. Yeah, the question was, if you have an expression with different data types in it, you know, how does it resolve that? How does it know which data type to use? We can talk about that, absolutely. That's great. Great thing to think about. It can get pretty complicated, actually. We've only shown you, I think, 4 types so far: int, double, boolean, and string. There are more than that. So, you know, once you take that into consideration, things can get even more complicated. But I'll try and distill it down to, you know, the information that you need for the exam and what's relevant to this class. It's always going to pick, if I'm mixing 2 different data types together, it's always, the result is always going to be the widest. what's called the widest type. Wide, like physically wide, right? So what do I mean by that? Some types are capable of representing more values than others. This should be very obvious. Boolean can only represent 2 values, true and false. Ints can represent a lot more than 2 values, right? But still not an infinite number. The actual number of integers that can be represented is in like the 4 billion range, right? Doubles, they can represent, they use exponents. They use scientific notation if they need to. If the values get really big or really small, they'll use scientific notation. So the range of doubles is huge, absolutely gigantic. And then strings, I would argue, are the biggest of all, because I can have an integer value as a string. I can put 7 in quotes, right? And that is a string version of an integer. I can do the same thing for a double. And then I can also include all the text as well. I could put the words hello and goodbye and everything else. So of the types that we've talked about, a Boolean is the skinniest. It has the fewest number of values. And string is the widest. It has the most number of possible things that it could represent, right? The number of strings that I can conceive of is very, very, very large, whereas there's only 2 Booleans that exist in the whole world. What does that mean for us? The question was, all right, if I'm combining things together, how do I know what the result's going to be? It's always going to be the widest. So if I am, adding an integer to a double, right? An integer could not capture this answer. It's not capable of representing this result. So it would want it as a double. In fact, if you try to capture this as an int, Eclipse gets mad at you and says, this has to be a double. There's decimals involved. Int is not capable of representing double values, so you can't do that. So if you're ever talking about, integers and doubles mixing together, double is what it's going to be, because that's the wider type. It's capable of representing more things. If you start to throw strings into the mix, string is the widest one of all. So if there's a string in there, that's it. It's going to be a string, guaranteed. That is the type of the result. So this will be a string. However, be careful. Be careful. Which operation am I going to do first? Nope. Good guess. I'm going to do that first. How do I know? Order of operations. The same order of operations that you learned in algebra class. Same ones. Same ones. So if I have multiple addition statements in the same row, I just go left to right. I just go from left to right. So it's going to do this first. It would say 12.6, right? And then it'll concatenate the high on the end. So that's what I would expect to see back out. We can verify that by printing it. Oops. Oh, whatever. Yeah. 12.6. So order of operations still applies. Order of operations still applies. PEMDAS or whatever you learned, that is still in effect here. Yes?
So high was first. It was high plus 7 plus 5.6. Would it be 8i 7 5.6?
Great question. Let's try it out. I think you're right, but let's verify. There you go. Yep. Order of operations says that, and actually, I think it's important to note that addition and subtraction have the same precedence. So anytime you have addition and subtraction, it's left to right. Correct? Subtraction is not more important than addition. That makes this an error. You can see that because this happens first and the result is a string, and I can't subtract things from strings. That's not allowed, right? That's not a thing that can happen. But if I switch the order back and I make this subtraction, that's a-okay. This subtraction is going to happen first. I get a double back out, and then I concatenate the string back on. That's not a problem. It's not a problem at all. Order of operations still in effect here. Yep. Now let's talk about that a little bit more because I think, when I say order of operations, people understand that part. But what makes things even trickier is that we have more operations in this class. Yes, we have addition, subtraction, multiplication. Yes, we can use parentheses to clarify order of operations when we need to. That's all familiar stuff to us from math class. But we also have greater than, less than, equal to, right? We also have things like and or. So where do those fit into the order of operations? This is something that is going to matter on the exam. And so, we're talking about operator precedence in Java. You can tell that this is something that I don't have this stuff memorized. This is not worth memorizing in your brain. I look it up when I need to. But here we go. Stuff at the top means it happens first. Stuff at the bottom means it happens last. So we haven't covered all of these things. If you see symbols, you're like, I don't know what that is. Okay, we haven't covered it. Don't worry about it. But some of the stuff we have covered. Here's multiplication, division. Oh, and hey, modulus. Well, modulus is kind of like division, right? So that's probably not a surprise to see it there on the same level as multiplication and division. That's first. Parentheses aren't included here, but parentheses do in fact work the way you expect them to. They will take precedence over everything else. They would be at the very top of the list if they were on this list. Here's addition and subtraction. And then down here we see, there's relational operators. Greater than, less than. Here's equal to, not equal to. And then down here I see ands and ors. So for the purposes of the exam, right, you can kind of break it into three categories. Arithmetic happens first. If you see math, you got to do that math first. And do it according to, typical order of operations, PEMDAS or whatever acronym you learned in math class. So math first. Then after that, we're going to do relational operators or comparison operators. That's another name for it. Greater than, less than, equal to. That's the second category. So after I do my math, I'll see if there's any inequalities. I'll do greater thans, less thans, all that stuff. And then the third category is the logical operators. That's and, or, and not. So math first, then comparisons, then your logical ands, ors, and nots. For the exam, that'll get you there. There is more to it than that, but for what we've covered, that's the deal. Any questions? Any questions about that? Yeah.
If you have like a system that has 3 plus 1 plus string 1, it outputs 41. But if you have string 1 plus 3 plus 1, then it's 1, 3, 1. Why does it change? You have the string change.
Yeah, I mean, that's, I think, almost the exact same example that we just did up here. It's the same answer. It's order of operations. So, if I do 1 plus 3 plus 1, order of operations says I do multiplication, division first. There isn't any. So I do addition and subtraction next. There is addition here. There's actually 2 of them. So which one do I do first? I go left to right. I do this one first. An integer plus an integer is going to give me an integer, 4, and then a string 1. But your question was, why is it different if I take the quotes off of this one and put the 1 here? Well, order of operations still applies. I'm still doing this first. So a string 1 plus 3, that's not an integer 4, right? That is a string 13. Order of operations is still in effect here, yeah. And then this, since this is a string, it is now string plus integer. That is still a string at the end. Yep. Any other questions? Any other questions? Any other topics or practice problems you want me to look at, or you just want me to pull one up? What's up?
Something with like another 4 each loop in it.
Another for each loop in it? Yeah, sure. I'm going to do this code reading problem next. I think this is a good one. And I want to talk to you about the code reading problems anyhow, because there will be some on the exam. So for this style of problem, the goal is to write down on a sheet of paper, get out a sheet of paper or something and write down what you think is going to be printed when this code is run. Obviously, you can run the code in C, but I hope you take the chance to write your answer down first and work through the code, because that's what I'm asking you to do on the exam. So I'm really asking you to be the debugger. That's honestly what I'm asking you to do, is walk through this code line by line and keep track of everything as you go through. So let's do that. Let's go ahead and do that. Take a look at this code, walk through it step by step, and see what we're going to get back out. I've actually got two arrays here. I've got this integer array called next, and I've got this string array called out. And here is our for each loop. Here's our for each loop. Again, the way that I would read this in English, I see the colon here, so that tells me right away, for each loop. Not a for loop, but a for each loop. Okay. For each integer v in next. That's how I would read that. The first time through this loop, v is going to have a value of 2. The very first value from the collection. The second time through the loop, v is going to have a value of 3. This value, right? And then 5, and then 3, and then 1, and then 0, and then my for each loop is over. Okay, so now we can use that to maybe kind of try and figure out what this problem is going to do for us. I'll start writing some things down here. I said, okay, the first time through the loop, v is equal to 2. But what's getting printed out? What's getting printed out is this. So I'm taking v and I'm using it as a, what's that word again? As an index. I'm using v as an index into this array. So really what gets printed out is out of v. V is 2, so out of v is what? A. 0, 1, 2. A. Everybody with me? All right, next time through the loop, it's a for each loop, so v is going to be equal to 3, which means that out of v is equal to the u, right? If this was 2, and this is position 3. And then at this point, I think for most people it kind of starts to click, right? How this is going to work. It's just going to repeat this process until it runs out of numbers. So you can kind of just fill in the blanks. 5, 6. There's 6 values in this array. So I expect my for each loop to run 6 times. It's going to go 2, 3, 5, 3, 1, 0, the exact same order, right? These numbers are going to appear in the exact same order as they do here. And so then I just plug these values in. This is the answer. And you can verify that by running code. If you're working through these and you're like, I don't know how it got that in. Like, what? Where did it get that word? What? I don't understand why that letter's there. Use the debugger. I love using the debugger. You can see I actually worked through this problem in the last session, and I still have my breakpoint set from when I use the debugger on this problem. You set a debugger on the exciting part. I put it on the loop. I'm going to run this in the debugger, and I can see what the value of v is on every step. Okay, there's v. v is 2. I'm now about to print out whatever value is in this array at position 2. 0, 1, 2. All right, there's my A. Right, there's my A. Next time through the loop, v is 3. There it is right there. There's my u. there's my T, there's my U, there's my M, there's my N. And then I'm done. Another way to think about it, right? Let's say I came back up and switched some of these numbers. Hopefully you can see how that would affect the code. What do I expect to see now? I expect to see, you know, A, U, 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 N. The for each loop is going to take on each of these values one at a time in the exact order that they appear. Cool? Any questions? Be happy to re-explain, go over that again if you would like me to. Okay. Any ideas as to where we should go next? A topic you'd like to look at, a practice problem you'd like to look at? Yes? I don't know if I have any image ones, but I think maybe I could do a problem that would be along those lines. Where's the one I was thinking of? Nope. Nope. Oh, I know it's here. Ah, yeah. Let's do this one. Transposition. So I don't know if any of you have, taken any linear algebra or done any work with matrices or things like that. But this is asking us to do a transposition. It's actually a very straightforward concept. I have a two-dimensional array of values. And so this is row 1, and this is, I'm sorry, that's not row 1. This is row 0, and that's row 1. After transposition, the rows become the columns. So row 0 becomes column 0. You can see the 1, 2, 3 going down the columns. And row 1 becomes column 1. Right? That's our goal. So I am given this, and I wish to create this. It's a similar situation, though, to our previous example with arrays, right? If I give you an array that has, 3 rows, I would expect your code to still work. If I give you an array that has 100 rows, I would expect your code to still work. So we need to write it with that in mind. Okay? So here, we've been given an array of data, and we wish to transpose it. First step is let's create the transposed array, right? Let's create the array that's going to hold our transposed data. I need to specify, well, for starters, how do we create this array? I would use brackets here if I knew what values I wanted to put in. But remember on the exam, that's not going to be here. It's just going to say like ... or something, right? You're not going to know what the actual numbers are. So you need to think about the other approach, which is to create an empty array and then copy the values over. I think that's the approach we're going to take here. So when I create an empty array, I have to specify how big it is. So the number of rows in this array should be equal to the number of columns in the original array, right? And the number of columns in the transposed array should be equal to the number of rows in the original array. We already talked about how to retrieve the rows and columns from an array, so I'll just go ahead and stick the number of columns in here. Right? This is the number of columns, that's going to be my new number of rows, and this is the number of rows, that's going to be my new number of columns. Everybody with me? I hope. Yeah? Okay. For this problem, do I need to visit each and every single one of the values in this two-dimensional array, or am I going to skip some of them? Do I need to visit each and every single one of these values, or am I going to skip over or choose them randomly? I need all of them. So if I'm ever working with a two-dimensional array, and I've made the determination that I need to visit each and every single spot in that two-dimensional array, that should be your big flag, right? This is where nested loops come in. This is a perfect situation where I want to use nested loops to solve this problem. And so I think, the classic version of nested loops is what we want here. I even usually go so far as to indicate the first loop is for the rows. The second loop is for the columns. You'll notice how fast I'm typing this out. That's because, again, I've used this nested for loop structure I don't even know how many times, hundreds, thousands. It's a very, 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 very common way of approaching two-dimensional arrays. So we need to extract the value from this array and then figure out where to put it in our transposed array. So to extract the value from this array, we would say data I and j. And then when we transpose, the rows become the columns become the rows. So actually, where does it go in the transposed array? I would just flip those. Whatever the row is in my original becomes the column of my transpose, and whatever the column is in my original becomes the row of my transposed array. That'll do it. I think that's the answer to the problem right there, as given. If we wanted to verify, we'd probably need to do a little bit of extra work here and print out the array, print out the contents of the array, which can be done, with the exact same nested for loop structure. Again, not necessary to do this as part of the problem, but I'm doing it just to verify that things are working properly. I need to switch this to say transpose instead of data, since that is the array that I wish to print out. Bracket. All right. So we're given this array with 2 rows and 3 columns. If this code works appropriately, I would hopefully expect to see, I need to be a little careful about how I print these. Well, let's run it in C. Let's run it in C, actually. Let me make the mistake. 2 out of bounds for length 2. What did I do wrong? I did some. Oh, I did. Thank you. Thank you. Copy paste. Sloppy copy paste. Let's try that again. All right. So this is the results of my transposed array, but it doesn't really look like a two-dimensional array, right? That actually has more to do with how I printed things out, how I printed these values out. Remember, there's more than one way to print things. If I take this off, that kind of gets me in the right direction. Now I see it going across instead of down. What I actually need is a combination of the two, right? Combination of the two. I need to tell it to move to the next line at the end of every row. And since this loop represents the rows, I'm going to go to the end of this for loop, which would be right here, and tell it to print out an empty line. Move to the next line, and we'll finally get the proper visualization for our 2D array, where we can see that the values are going down the columns. But again, just to be, I know I've already said this, but just to be like super duper clear, I should be able to come up here and add another row, or 2, or 3, or 7, right? And it shouldn't matter what the values are either. And I should be able to run this and still have it work. Should still be functional, regardless of how many rows or columns I've included. Any questions about this one? Anything you'd like me to go back over or anything like that? Okay. Looks like we still got about 35 minutes. Definitely have time to go through at least 2 or 3 more of these problems. If anybody's got one. Yeah, what's up?
Yeah, so my question is, could you just have the system print an array where it printed all of them like that, or would you have to have like the internal?
Sure, let's try it. All right, so I got rid of all that loop business and just said print. That's what I got. Anybody remember what that is? Talked about it in class last week, I believe. That's the memory location where the array lives on your computer. Not very useful for us. Slightly interesting perhaps, but not useful for us. This is never something that you would need in this class or on the exam. The proper way to view the contents of the array is to use loops. That goes for one-dimensional arrays as well, not just two-dimensional arrays. Have to use a loop to go through and print out the contents of that array. Yeah, any other questions on this problem? Any suggestions or ideas on where to go next? Any topics you want to talk about? Any? I'm sorry, we have. Oh no, we don't have 35 minutes left. We only have like 4 minutes left. I'm sorry. I probably don't have time to go through anymore, do I? I read my clock wrong. Sorry about that. I guess now's probably a good time to wrap it. I really don't think I have time to go through anymore. So I'll go ahead and wrap it up. If you have any questions, I'd be happy to stick around for a few minutes and chat with you after class. Otherwise, good luck on the exam, and I'll see you in class on Wednesday or Thursday perhaps, or definitely at the exam on Thursday night. Thanks, everyone.